Hello Dr. Hawking.
Hello Dr. Einstein.
Good afternoon, Dr. Hawking.
Good afternoon, Sir Isaac Newton.
What a clear weather today.
I agree.
Nature shows us only the tail of the lion. But I have no doubt that the lion belongs with it even if he cannot reveal himself all at once. We see him only the way a loose that sits upon him would.
To me, nature is all about material atoms where the fundamental characteristic of nature, bound together by the force of gravity.
I would personally quite claim that I praise your value for the gravitational constant.
It took me quite some time to figure it out.
Nonetheless, it is extraordinary since it emphasizes the relation between gravity to the masses and the separation of bodies.
Precisely. Furthermore, if the value for the cosmological constant was a little bit more, most of the existing stars and possibly large planets would turn abruptly to black holes. And if there were still remaining stars floating around, they would be short-lived, meaning that their lifespan would be relatively short since their nuclear fusion won't be able to counter the force of gravity. On the other hand, if the value for the gravitational constant was a little bit smaller, stars wouldn't have had the chance to form and possibly will direct us to abandon the notion of a living universe.
That's the physicist answer. Now let me give you the cosmologist answer.
Oh wow! I did not expect
Lord,
that. Ha
well
ha
said,
ha ha
Dr.
ha.
Stephen. Ha ha.
All right. When you take the luminosity of a star into account and play with Sir Isaac Newton's value of the gravitational constant, you will soon realize that the luminosity is extremely sensitive. This makes you wonder if the constant of the gravitation does ever change over time, and according to us cosmologists, we imply that the universe is evolving over time and is never stationary because according to quantum mechanics, nothing is ever stationary. Thus, the laws that govern the universe might also change, and so will the constant values.
Interesting. I thought that the universe was static. But it later turned out that this is not the case.
Same, while I was coming up with the field equations that would explain how gravitation worked, which illustrated that matter tells space how to curve and space tells matter how to move. In 1917 it was to my surprise that I soon realized that my field equations required an evolving universe that contradicted the observations of the astronomers at the time. As a result, I immediately rushed to my work to fix the issue, and in the end, I included the term lambda representing the cosmological constant.
Interesting indeed. In my third book of Principia, I also tried to show that the universe was static since, in every direction, the universe appears to look the same. So I wrote that an observer is rotating and thus experiencing inertia. Is it possible that this is yet another case of relative motion and is indistinguishable from a case where the observer is at rest and the rest of the universe is rotating around him?
Yeah, as I said, the universe is evolving and will keep evolving forever. In the very future, the universe will have expanded to a freezing point where all forms of life would be gone. Remarkably, that just got me to think about time travel.
Time what?
According to my theory of time dilation, time travel to the future is possible for moving observers. In other words, the faster you move through space, the slower you move through time.
Irrationally, time travel to the past might be possible with a time machine.
With all due respect, Dr. Hawking and Dr. Einstein, your fictional proposal violates my first law of motion, which states that objects tend to stay at rest until they are acted upon by an external force. Meaning, that nothing can move from one point in space to another with a click of a button.
My sincere apologies, Sir Isaac Newton. I meant objects such as wormholes that possibly allow form time travel according to modern mathematics.
That is right. Soon after my theory was published, the possibility for such an object to exist was probable, and I wrote a paper on it.
In case you didn't know, time travel to the future is possible. The faster you move, the slower you age. To illustrate, if you spent almost your entire life on an airplane, you would have aged merely 0.00005 seconds. But we face plenty of challenges in the study of cosmology with time travel to the past. Challenges such as the twin paradox may violate causality. In other words, one cannot go back to a timeline and prevent something before he was even born. Moreover, it may violate the Pauli exclusion principle, which states that particles with the same quantum state cannot exist at once, meaning that even if one managed to travel to a timeline after one was born, one cannot touch their other previous self, else the principle may be violated, invoking possible chaotic destruction between the two. However, if the particles that make up the twins were not in the same quantum state, there could be reasons for that which may vary, for example aging. In this case, it may be safe for the twin to touch or interact with each other. One implication that may give a way out of the paradoxes is the theory of the multiverse. The theory of the multiverse suggests that there are infinite possible universes and parallel universes that do not necessarily allow for paradoxes and the violation of causality, since there are plenty of possibilities for the arrangement of the molecular structure and quantum states in one's parallel twin body.
Very well, thank you for your invitation, Dr. Hawking. Have a great day.
You too.
Thank you, Dr. Hawking. Have a great day.
You too. My pleasure.